Hey everybody, I am so sorry that I haven't been in class the last couple of days. Stomach flu's been kind of tearing through my house. My little one had it and I was home with her and then she gave it to me. And so I've been pretty sick the last couple of days. I've been getting some messages, people not understanding the lab assignments. So I thought I would kind of run through some of these notes and just give you a little tour as needed so that we can hopefully get through this a little bit better. So, density, as one would hope you know by now, is mass over volume. It's a ratio of how much of something there is and how much space it takes up. Density is a unique property to substances in that it can be used to identify them. If you have something that looks like gold, sounds like gold, smells like gold, but doesn't have the same density as gold, it's not gold. We measure mass in grams, kilograms or milligrams, but usually just grams. Volumes either in milliliters or centimeters cubed. Now, centimeters cubed and milliliters are equivalent to each other. They mean the exact same thing. The definition of a milliliter is a box 1 centimeter on each side. So you can interchange those two back and forth whenever you want. We typically use centimeters cubed for solids and milliliters for liquids. Now, when you're solving for density, it's simply mass divided by volume. You got to make sure that you have mass on top, volume on the bottom. And when you divide mass by volume, you get density. Now, the units for density are a combined unit, grams per cubic centimeter, or grams per milliliter, or kilograms per kiloliter. It's always something per something else. It's always a unit of mass per a unit of volume. So that sets up a nice proportion for density. Now, what you are going to be doing more often than not is using some measurements, and from those measurements, ultimately getting density. Let's say we had this rectangular block that I have drawn so very well. It has a mass of 120 grams. It has a length of 6 centimeters, a width of 3 centimeters, and a height of 2 centimeters. Pick those numbers to make it easy. This is the raw data. Volume of a rectangular solid is length times width times height. Not length plus width plus height. Not length divided by width divided by height. Not length minus width minus height. Times 6.00 centimeters times 3.00 centimeters times 2.00 centimeters. And notice I'm leaving the units in the calculation. 6 times 3 is 18, times 2 is 36. Centimeters times centimeters times centimeters gets you combined unit of centimeters cubed, which is a unit for volume. Now, to figure out the density of this object, we take its mass, the 120 grams, divided by the calculated volume, 36 cubic centimeters, and we wind up with 3.33 grams per cubic centimeter. We're trying to identify it. And let's say these are the three possibilities of what this object is. Gold with a density of 19.3, aluminum with a density of 2.7, and copper with a density of 8.95 grams per cubic centimeter. This value So, I apologize if this is a little choppy. My little one's right here eating, and you can hear her laughing and demanding attention and more milk. Anyway, I believe I left off with. So we've got the density of 3.33 grams per cubic centimeter of this unknown object. These are the three possible identities. The closest value to it's 2.7, so we would say this is probably aluminum. It's definitely not copper. The density is about 1/3 of that, and it's definitely not gold. Gold's about 6 times more dense. Now, when you do your measurements, you should get much closer numbers. In your pivot, you have 6 substances to choose from, and I'm just going to randomly pick substance 3 right now. When you hit play, they will put the block on the scale, so you have your mass. Using the ruler tools, you can measure the length And remember, this is a standard centimeter ruler, so your measurements are going to be to 2 decimal places. You can do a vertical ruler to measure the height, and then let the video play so that they can adjust it. And now you can get your final measurement, which was width. So you now have the mass, the width, the height, and the length, all 4 values you need. So with question number 4, select one of the objects from the list. I selected number 3, so I would type something like object 3, mass equals something grams, length equals something centimeters, width equals something centimeters, height equals something centimeters. Volume equals LWH equals whatever the length was in centimeters, times whatever the width was in centimeters, times whatever the height was in centimeters, equals something centimeters, and you can do it that way as centimeters cubed. Last thing, we need the density. So you will take the mass and your calculated volume and divide those. Density equals mass divided by volume equals mass in grams divided by volume in centimeters cubed equals something grams per centimeter cubed. That gets you your density of object 3, let's say. Then I say select one other object, which means you'll do the exact same thing, except you're going to pick something other than object 3. Load up object 1. Load up object 5. I don't care. But load up 2 objects, run the videos to get the data. Now, in question 6, here's a table of densities. What is the composition of the first metal sample you measured? So we calculated density here for object 3, and we're going to try to match it to one of these. So we can say object 3 is blank. If the density calculates out to 4.45, hey, titanium is 4.5, it's probably titanium. If your density calculates out to be 11.4, well, that's pretty darn close to 11.3 here, it's probably lead. Then you do the same thing for the second metal. That's how this lab is supposed to work. I should hopefully be back next week. I hope this helps. Feel free to send me messages on Google Hangout if you have more questions.